Now, okay. Yeah, beta. So chapter 6 we were discussing. Chapter 6 में I'm discussing about the EMI chapter. है ना? EMI. So in this EMI, so before going to this topic now, one thing I would like to say you very clearly. What does that mean? See, 1, 2, 3, 4, 5, 6. Sixth chapter is going on. Before I teach this sixth chapter, a child should understand this process very clearly. He should understand. The child who has not studied the first chapter thoroughly, he will not understand the second chapter. Because here, whatever we talk about the electric charges, we talk electric charges in rest condition. All the charges are in rest condition. So in this completely, we see the derivations regarding the rest charge, Coulomb's force, or multiple forces, or electric field. All these things we are seeing here, electric charges. When you study very thoroughly, then the relationship is there with the electric charges and the electric potential. So this is having complete relationship. Electric charges. Whatever you studied in the electric charges, topic will be the same. Almost same topics will be studying in electric potential also. But here we talk about the same discharge only, but we talk about the potential, electric potential. यहाँ पे बात कर रहे हैं. और current electricity is a different topic. Current electricity we talk about the moving charges. Completely, charges are flowing. So charges are flowing. That is called a current. Flow of charges is called a current. So charges are flowing is called. यहाँ पे current electricity के बारे में completely until different process we are studying. Then in fourth chapter, the topic itself, name itself is called a moving charge. Completely charges are flowing. When a charge is flowing, Einstein experiment. Based on the Einstein experiment, when a charge is flowing around a conductor, what happened? Magnetic field will exist. And this magnetic field, regarding we talk about the magnetic field. So if a charge flows in a conductor, what could be the magnetic field here? And what could be the magnetic field here? What could be the magnetic field here? So how we all these things we related regarding the Biot-Savart law. One more scientist he said about the Biot-Savart law. He brought the concept, he brought the formula, everything. Then we understand how much magnetic field will be there. All these things we studied. Not only that, magnetic field due to straight current we studied, magnetic field due to a circular coil we studied, magnetic field due to a circular coil at the center point we studied. Everything we studied in the moving charges. Fifth chapter, magnetism. The magnetism chapter, I told you, 90% of the magnetism topic is related to the first chapter. तो देखो बेटा, ये कॉन्सेप्ट आपको समझ में आना चाहिए. You should remember very thoroughly. So when you don't understand the chapter 1, chapter 2, chapter 3, chapter 4, constantly, if you don't understand this, then further moving is very difficult for you. That's what I would like to tell you here. That's why each and every class is very important for you. सर मैंने फर्स्ट 2-3 चैप्टर छोड़ दिया सर, तो मैंने 5th चैप्टर नहीं समझ में आएगा बच्चों, नहीं समझ में आएगा. Everything you looks very new for you, so you find difficulty. Then see, now what is the problem is, up to 5 chapters we finished magnetism. Now the chapter 6 is called EMI. Chapter 6 is called EMI. Electromagnetic induction. I am going to talk about the induction. Induction means what? Induced current. We are going to talk about the induced current. Induced EMF. So again we are going to talk about the current and EMF. But this EMF and induced current is totally dependent on which chapter if you ask me. So this 6th chapter is completely related to the 4th chapter. Moving charges. So those who don't understand the moving charges, they find difficulty in EMI. Whatever I'm telling you, do you understand or not? Jaldi boliye. Do you understand?
Yes, sir.
So please interact. Bachchon, please interact. Are you getting my point or not?
Yes, sir.
So, bachchon, what you should do, you should have a thorough concept. Concept clearance should be there. Concept clarity should be there. First chapter mein, if a child, if I completed first chapter means I should close the book. I should not have a book, any book or any reference book, anything open in front of me. I should say on my own, what are the contents I studied in electric chapters? I should start studying the electric charges first chapter mein, from the page 1 to page end. What are the topics we know? How many formulas? 45 formulas. Whatever the formula you ask me, sir, I'll be able to say that. So that is the confidence. तो ऐसा आना चाहिए. और उसके सब टॉपिक, all the subtopic, without the book, you must be able to say that. So this, when you will develop this means, when you have a constant, regular, daily touch with the subject, then the physics in your hand only. Really I'm challenging you बच्चों. तो ये समझ में आना है. तो देखो बच्चा, अब जो बच्चा है ना, first, suppose if you are attending new, suppose if you are attending my first class, this is the first class, you don't know about all the 5 chapters. You are going to learn the 6th chapter. Then the child, if I teach some concepts, na, I'll ask the question, then for the new child, they find very, very difficult. अरे भाई ये क्या बोल रहा है, समझ में नहीं आ रहा है, ये कहाँ से आया? So that is the difficulty. If you are an old child, a child who studied already the 5 chapters, who is thorough with the 5 chapters, if I ask the question, then immediately he will be able to at least understand. हाँ yes, ये तो सर पहला पुराना क्लास में बोला था बोल के आपको रिलेट करें. Okay, so what I would like to tell you. Please never miss the class. If you miss even a single class, then it is a very difficulty for you. But that's why I'm telling you, please don't miss the class. Don't miss the class. बोल के हमेशा मैंने आपको बोल रहा हूँ मैंने. Okay बच्चों, now we'll go to the subject straight away. EMI, chapter 6, EMI, electromagnetic impact. In this first, what we are going to learn means, so as I told you yesterday, Einstein, what discovered Einstein? Einstein, the concept we know, straight current carrying conductor. When a current is moving through the conductor, straight current carrying conductor, it produces a magnetic field around the conductor. So this is called magnetic field. When current is going straight, so you can put here, when current is going straight around the current carrying conductor, magnetic field is produced. This was said by the Einstein. So vice versa is thinking. When a magnet is moving, with current is produced. When magnet is moving, when magnet is moving, will current produce? Will current produce? So ये doubt था scientist को. So it was made by successful by Faraday. So Faraday discovered this. Yes, if you move the magnet, then current is also produced. How? That's what we are going to see. Yesterday I taught you that. Straight away we are going to that. So see here, Faraday's experiment. How Faraday, he did 3 experiments. Okay, he did the 3 experiments. All the 3 experiments. First, we'll understand what are the 3 experiments he did. First experiment. So Faraday डालेंगे नाम. Faraday experiment. The first experiment what he did means he took a coil, and coil से क्या करा भाई? खाली सिर्फ he is connected a galvanometer. He connected a galvanometer. Okay. Simple coil is there, and when current is there or not, to check the current flow, a galvanometer he has connected. Now what he did, he is forcibly moving a magnet. He is forcibly moving a magnet towards the coil. He is forcibly moving a magnet towards the coil. Yes, he observed that current is produced. So current he saw that a deflection is produced in the momentary deflection is produced. And he moves the magnet towards the coil like this. Forcibly moves the magnet towards the coil. This is the coil. Imagine that this is the coil. This is the magnet. So he's making a magnet. So this is the coil. So this is the coil. Imagine that this is the coil, and he's making the magnet to move very forcibly towards the coil. He's seeing the momentary deflection. So he's seeing momentary deflection, not instant deflection. So momentary deflection. He observed. From this, what he concluded, yes, when a moving magnet towards the coil, it produces the momentary deflection. Current is produced. Then again, what he saw, so far, he moved a magnet like this. Now again, what he's seeing, second, this is the A. B part, what he's doing means he is making the magnet to move a reverse direction, like this, north pole, south pole. He is receding the magnet away. So this is the velocity in this direction means now the velocity in the opposite direction. So again, he is seeing that. Again, he is seeing the deflection in the opposite side. Deflection in the opposite side. So momentary deflection, again he is seeing the momentary deflection. Momentary deflection. Okay. Now third one, what he is doing, third one, when you make the magnet towards the coil, or when you move the magnet recedes away from the coil, he is seeing in both the cases, he is seeing the deflection. But third case, what he observed means, third case, suppose if you take the coil here, okay, coil is connected with the galvanometer. Now the magnet is here, North pole, south pole. But magnet and coil both are in rest condition. Both are in rest condition. No movement. Rest condition means no movement. So magnet, there is no arrow mark towards the coil, are not going away. So it is in rest condition. So he observed that no deflection. no deflection. Please note down all these things. So when you move the forward movement, he saw the deflection. When you make the movement backward, again he saw the deflection. If it is in rest condition, he observed that no deflection. Okay,
नहीं सर,
please
रुकिए
note down.
थोड़ा।
Okay, note down. Let's make it fast. Okay.
Yes, sir.
1,
Yes, sir.
2. Just simple word to note down. Okay, Ashley, on the board.
Done sir.
Yes.
Okay. All of you? All of you finished?
Yes, sir.
Okay. Next, what he observed means second part of this is the first part of the experiment. First part of the experiment, he took a coil and magnet. That's all. He took a coil and magnet. Okay. So this was done by the Faraday experiment. He observed forward direction, reverse direction, reverse condition. Okay. So ABC. Second part of the experiment, what he did. Now, in second part of the experiment, what Faraday observed, we will see. Now see here, instead of the magnet, what he is going to do means, he is taking a coil, same thing is taking a coil here, and this coil is connected with a galvanometer. Usually this left hand is changed. Left side is the same condition is there, same thing is there. So he connected a galvanometer here. Okay, coil, and galvanometer. Now he is taking instead of the magnet, he is taking one more coil here. One more coil he is taking. So this coil, what he did means, this coil is connected with the battery. This coil is connected with the battery. This is very children. So here single coil is the one coil he has taken. This coil is connected to the galvanometer. Here there is no current at all because single coil is there, only galvanometer is there. So no chance of flow of current at all, nothing is there. Only coil and galvanometer is there. But here another coil he has taken instead of the magnet. Instead of magnet, this is the second part of the experiment. Instead of the magnet, he is taking a coil, but this coil is connected with the battery. With the battery. Okay. Now, what this battery will do? Battery supply the current. Battery supply the current. So current flows like this, and the current flow, and then it will end up with the negative charge. So when the battery is supplying the current, now we understand very clearly when a current moves in a coil, we understand very clearly, behaves as a magnet. It behaves as a solenoid topic we finished. So fourth chapter we finished the solenoid. So when the current is moving in the coil, then it behaves as a magnet. And so instead of this, whether you have a coil or you bring the magnet, both are the meaning is same only. That means we understand meaning is same. So what happens? He is moving the coil forcibly towards the second coil, the first coil. This is the second coil. This is the first coil. So coil 1 and coil 2. So when he moves the coil, when the current is moving here, so when he makes the movement of this coil here, he is observing that. He is to observe that whether the deflection is produced. Yes, he observed that deflection is produced in one direction. Then when he moves the coil in the second, this is the A part, B part, and C part. So A part, when he's making the movement of forward direction, so he observes the deflection one side, and when the coil is moved in backward direction, this direction, we'll be seeing the deflection in opposite side direction. The deflection is in the opposite side direction. When he keeps both the things rest condition, so rest condition, no deflection. Now, from first experiment, first part of the experiment, second part of the experiment, what do you understand? So we understand very clearly, relative motion should be there. Either so either the magnet, if magnet is there, magnet should move or the coil should move. So any one should move. So when movement is there, then deflection we observe. So either the coil you move in the forward direction or you move the coil backward direction, you saw the deflection. But if they are in rest condition, you cannot see the deflection. So this is what we observe. Okay, make a note of it. Second part of the experiment. So noting down, please continue. Go to the third part of the experiment. Okay. Over.
सर यही वाला 3 बार बनाना है ना?
Yes, tell me. Tell me. लो बोलिए, समझ में नहीं आ रहा, बोलिए.
So we have to make it 3 times, right?
Yeah,
Like
yeah,
which
yeah,
time?
yeah. A, B, C. One you make the movement of the forward direction, another one you make the movement of the reverse direction. You show the deflection. Show the deflection in the galvanometer. Third one you show the rest. Both of them are in rest condition, so no deflection. So no deflection in the first
Okay.
coil. Just you do the diagram. Diagrammatic questions. Only diagrammatic questions. हो गया. अयाज कर लिया बेटा. अयाज, आयमन, डरविन. Sharir, are you able to understand?
Yes, sir.
Okay. Play on the board. Hello, hello, hello. So speed से note कर लो बेटा. Don't worry, notes
sir.
will be given. For everybody, you will be getting the printable notes. Don't worry. But even though if I give the notes, better you write one time. When you write in your own handwriting, you will understand.
Okay.
After finishing every chapter, I will send you the notes. Don't worry. Bachcho, all the children, nothing to worry as usual. After finishing every topic, I'll be sending you the notes. Okay, now third part of the experiment. What you will see here. All are Faraday's experiment. Okay. Third part of the experiment, what he did means he is taking a coil. So this coil is connected to the galvanometer. Okay, usually left side we will not change. Coil is connected to the galvanometer. Then here, now he is taking one more coil here. So this coil is connected with a battery. Battery. Positive, negative, positive, negative. Battery with the key is connected with the key. Battery is connected now. So coil 1, coil 2, coil 1, coil 2. Now, can you say now, with the deflection, can you observe here? This galvanometer, can you see the deflection here? Tell me yes or no.
Sir, no deflection.
Why no deflection?
क्योंकि key connect नहीं है.
क्योंकि
Key is not closed, sir.
which one is not closed?
The key.
Very
In
good
coil
boy.
two.
Who is that? Very good boy. Who is that?
Shake.
Sheikh Muhammad. Sheikh Muhammad.
Yes, sir.
Fantastic boy, fantastic boy. That
Thank you, sir,
means
very much.
it is just that magnet. Coil, therefore magnet is a chup chap beta hai. Nothing is there. Nothing, no movement, nothing is there. So when you press the key is open. Here key is open. When you press the key, then only the current will flow. Then only the current will flow. And here what happens means there is no movement. Here there is no movement. So what happens means from the rest condition, all of a sudden the current starts flowing. All of a sudden the current starts flowing means when the current starts flowing, when you press the key, the current is started flowing. So what happens? Even though the relative motion is not there, momentary deflection you can observe. And second point, first part, please listen very carefully my wordings. Please listen very carefully my wordings. When you press the key, the current flows all of a sudden. The current flows immediately. That is sudden current flow is there. When the sudden current flow is there, you can observe the deflection. Then what happens? You are keeping that second point, what you are doing, you are keeping that key is closed. Now continuously current is flowing. Current is flowing continuously. That time you cannot see the deflection. See what a beautiful concept. Slowly, slowly try to understand. When you press the key, immediately you are seeing the momentary deflection. But when a current is flowing in the coil, you cannot see the deflection. Afterwards, the deflection stops. Okay. Now, third point, what he's saying, again, you just switch off the key. So from on condition, you are making the off condition. That means the reverse current flow, off or on. So off on a time, that time also you can see the opposite side deflection, momentary deflection. That means, what do you understand from this experiment? When you switch on, when you switch off, sudden flow will be there, sudden flow starting, sudden flow stopping. Sudden flow. I'm using the word sudden flow started, sudden flow stopped. So in this condition only, you are able to see the deflection. But when a constant current is flowing in the coil, you cannot see the deflection. So this is what the concept we understand. So please write down the third part of the experiment. Write down when a coil, please write down. Below the diagram, you write down. When a coil is connected, when a coil 2. You do the diagram, leave the diagram space chhod do, diagram place space chhod do. When a coil 2 is connected with the battery and the key, when a coil 2 is connected with the battery and the key, when coil 2 is connected with battery and the key, then we observe the momentary deflection. We observe the momentary deflection in the coil 1. We observe the momentary deflection in the coil 1 only when the key is in on or off condition. When the key is on or off condition. Only when the key is on or off condition. Okay.
Yes, sir.
जी सर हो गया.
Next paragraph. We do not observe the deflection. We do not observe the deflection when a constant current flows. When a constant current flows. Okay. Over. बोलिए बच्चों, हो गया?
Yes, sir.
Yes. Now we go to the next definition. So this is what about the Faraday's law. Next topic is we are going to study define magnetic flux. Define magnetic flux. Maybe. Can anyone tell me what is electric flux का definition? Can anyone tell me what is electric flux? Anyone girl? Define electric flux. Anybody, anyone student. What is electric flux? First chapter. I told you, no, it is having the direct relationship.
Number of field lines passing through a given area.
Is called electric flux. Now the same thing can you change and modify here? What is magnetic flux? Same thing only. Say na?
Number of magnetic field lines passing through one point.
Passing through a point. अरे बोलना भाई सही बोला ना. Same thing you have to say na. Number of बोलिए number of
magnetic field lines passing through a area.
वाह बोलिए क्यों मैं इतना जल्दी होता है. Write down. Very good. So don't feel shy. मैं कितना बार बोल रहा हूँ. Don't feel shy. Please talk. So number of magnetic field lines. Number of magnetic field lines passing through a given area. Passing through a given area. Okay, बेटा. Magnetic फर्स्ट चैप्टर का इलेक्ट्रिक फ्लक्स का फार्मूला बोलिए. इलेक्ट्रिक फ्लक्स का फार्मूला बोलिए.
Psi equals radius cos theta.
तो phi
Phi sorry.
phi इक्वल टू रेडियस cos थीटा. तो इसको आई थिंक ये फार्मूला बना दीजिए. मैग्नेटिक फ्लक्स का फार्मूला इसको बना दीजिए. कैसा बनाएंगे?
Radius cos theta, sir.
Fantastic, boy. That's all. See how you are saying very beautifully. You are saying. I didn't say anything. You are only saying. So phi p is equal to b a cos theta. So this is the formula. So same formula. See. Phi b phi b equal to b a cos theta. So this is called positive flux, negative flux. Positive flux, negative flux. Positive flux, negative flux means if I take an area, okay. So for this area, this is the area vector. So this don't see like this. Otherwise, area vector will come like this. I cannot do three-dimensional figure. Imagine that the coil is like this. So coil is like this. This is the area vector. So imagine that the magnetic field lines passing through this lines like this. So magnetic field के लिए मैंने B vector बोल रहा हूँ और area vector के लिए मैंने n cap बोल रहा हूँ. n cap is the area vector. So magnetic field line and area vector both of them are in the same direction. If it is in the same direction, so phi b का value क्या होता है? Phi b is equals to BA. because cos 0 magnetic field line and area vector both of them are in the same direction means if the angle theta equal to 0 हो गया. Theta equal to 0 हो गया. So when theta equal to 0 means cos 0 is 1. So the answer is phi b equal to BA. Now the same point here you see.
Theta is equal to 1T.
Wow, very good. So this is the imagine that magnetic field lines are going in this direction, but I consider this is the area vector. Area vector opposite side का area ले रहा हूँ. So ये वाला n cap is the opposite side. This is the area vector. So here what we do, this from this angle magnetic field line to area vector angle देखना है. So 180 degree wide. So phi b will be equal to BA cos 180 हुआ. Cos 180 का आंसर क्या हुआ? माइनस हुआ. So phi b is equals to minus BA. minus B dot A. Therefore, plus B dot A और यहाँ पे हुआ minus B dot A. So plus means positive flux, minus means negative flux. हो गया?
Nice, sir.
Okay.
सर हो गया.
Okay. Now, next question is board question. SI unit of magnetic field. SI unit of magnetic field. Magnetic field का SI unit बनाइए. So this they will give you in MCQ question. MCQ में 4 options they will give. They will voluntarily they will make you to confuse, but you should not confuse बच्चों. आप confuse कभी नहीं होना चाहिए. तो आप ऐसा कर लेना है, okay? So SI unit of question is SI unit of magnetic field. SI unit of magnetic field. Magnetic field का symbol क्या होता है? B होता है. B वेक्टर होता है B contact. So what is the magnetic field का SI unit बनाने के लिए what formula we use? What is the help we get from where we get? Magnetic force हमको मालूम होना चाहिए. Can you not tell me what is magnetic force? Force क्या होता है?
IDL cos theta.
हाँ?
IDL cos theta. IDL by R square cos theta. Means sin theta.
Oh my god, oh my god. क्या कोई बकवास कर रहा है? I'm asking you magnetic force. Magnetic force का फॉर्मूला क्या है?
QVB
PIL.
sin theta.
Tell me.
QVB sin theta.
Very good point. So magnetic force will be equal to BQV sin theta. BQV sin theta. Magnetic force. Force on a current carrying conductor. Force on a current carrying conductor. What's the formula? Force on a current carrying conductor.
BIL sin theta.
Bill sin theta. Very good. Bill sin theta. So see that the children who are answering properly, from this we have to understand they studied thoroughly the 4th chapter. इसलिए मैंने बोला मैंने 4th chapter का रिलेशनशिप मालूम होना चाहिए. 4th chapter unless you study the 4th chapter, so 6th chapter is difficult for you. तो इसलिए मैंने बोला मैंने अभी देखो आपको मिल रहा है all we get from the 4th chapter. So this is the magnetic force formula. This is the current carrying force on a current carrying conductor का फॉर्मूला आता है. So force on a current carrying conductor has to F equal to Q sin theta. Magnetic force पूछा तो BQ sin theta. Okay बेटा, तो ये याद रखना. तो आपको नहीं भूलना चाहिए. Okay. So now, so this is the magnetic force का फॉर्मूला देखो. Magnetic force का फॉर्मूला QEB sin theta, BQ is anything it is. From this what I am taking means magnetic field B मेरे को चाहिए. तो B मेरे को चाहिए तो क्या होता है बच्चों? B is equals to क्या होता है? B ले लो F by QV sin theta. में करेक्ट? सही है? अरे बोलो सही है नहीं? सही है. B मेरे को चाहिए. Keep the F left hand side. Then send this all this QV sin theta down. तो QV sin theta हो गया. What is the flux formula? Flux formula क्या है? What is the magnetic
Phi
flux
sin
formula?
theta.
अभी भी बोले थे magnetic flux का formula क्या है? Magnetic flux. Phi B is equals to B into A. Magnetic flux is equal to magnetic flux. Phi B is equals to magnetic field lines passing through a given area. So BA cos theta. Cos 0 is what means phi B is equals to BA. तो B क्या होता है? Magnetic field होता है. ये क्या होता है? Area होता है. So first I will calculate the B. What is B? I am taking the B का help में कहाँ से ले रहा हूँ मैंने? Magnetic force का फॉर्मूला से मैं ले रहा हूँ. So F equal to B QV sin theta. From this I calculated the B equal to F by QV sin theta. Okay. Little bit difficult, but once you understand means you will not commit any mistake or you will not ask your friends what is the SI unit of magnetic field. थोड़ा एक बार प्रोसेस जान लिया तो आपने if you do how to do this, if you learn this means then no need to ask, no need to have complete doubt. डालने की पेन ये सब काम नहीं होता है. आराम से अपने खुद कर सकते हैं. ओके. तो B is equals to फोर्थ का डायमेंशनल फॉर्मूला क्या होता है? फोर्थ का डायमेंशनल फॉर्मूला जल्दी बोलिए.
MLT minus
क्या बेटा?
MLT minus 2.
हाँ, फोर्स इज फर्स्ट बेसिक फॉर्मूला बोला ना. SI यूनिट में सारे डायमेंशन यहाँ पे लिख लो. सॉरी बेटा, डायमेंशंस ऑफ मैग्नेटिक फ्लक्स बोले SI यूनिट ऑफ डायमेंशंस ऑफ मैग्नेटिक फ्लक्स. डायमेंशन. Yes, tell me. Force is equal to what is the Newton's second law formula? Newton's second law का formula क्या होता है? F equal to mass into acceleration. Very good children. Mass into acceleration. F equal to ma. So then q v sin theta. Now mass तो mlt फॉर्म में लिखना है ना मैंने. तो mass तो मैं m ऐसे ही लिख लिया. Acceleration का फॉर्मूला क्या होता है? डायमेंशनल फॉर्मूला acceleration का. Acceleration का फॉर्मूला lt पावर -2 lt पावर minus 2. Acceleration, rate of change of velocity. Acceleration is equals to rate of change of, rate means time, rate of change of velocity. तो velocity का फॉर्मूला क्या होता है? Distance by time. Distance क्या होता है? L by t, और यहाँ पे एक t है, so L by t square हुआ, तो t square ऊपर गया तो L t power minus 2. All these things we studied in 11th standard. All these things we studied in 11th standard. तो देखो बेटा acceleration का फॉर्मूला क्या मिला मेरे को? M t power minus 2 मिला, तो यहाँ पे डाल दिया. So मास की m को m कन्वर्ट करके एक्सीलरेशन का फॉर्मूला L t power minus 2 हो गया. और देखो Q का फॉर्मूला क्या होता है? Q चार्ज यू कैन राइट एज कूलम ना. हेलो चार्ज, जल्दी बोलिए.
C.
वेलोसिटी का फॉर्मूला बोलिए. वेलोसिटी का फॉर्मूला, डायमेंशन फॉर्मूला.
LT minus 1.
वेरी गुड,
LT
L t power minus 1. वेरी गुड, L t power minus 1. sin थीटा का डायमेंशन फॉर्मूला क्या है?
1.
sin थीटा का फॉर्मूला कुछ नहीं है ना. sin थीटा का डायमेंशन फॉर्मूला. हाँ, तो उसके बाद देखो d हो गया, तो अभी phi d का कैलकुलेट करेंगे. फ्लक्स का फॉर्मूला डायमेंशन का फ्लक्स, तो phi b will be equal to, और यहाँ b देखते हैं ना, b का फॉर्मूला सबसे, phi b equal to ba होता है ना. phi b equal to ba, तो substitute here phi b will be equal to, b का फॉर्मूला पूरा डाल लीजिए, m l t power minus 2 divided by c l t power minus 1. और एरिया का फॉर्मूला क्या होता है? एरिया का डायमेंशन फॉर्मूला
M square.
l square. वेरी गुड, l square. Now all you multiply. So before this, यहाँ पे देखो C L T power minus 1 है, C L T power minus 1 है. तो what is the current formula? current का डिफरेंशिएट करता है I equal to Q by T. I is equal to Q by T. इसका एक्सपेरिमेंट बना दीजिए. एम्पियर, कूलम, टाइम. तो ये T power minus T को क्रॉस मल्टीप्लाई कर लो, तो C T सॉरी ये को ऐसे रख लीजिए, T को ऊपर ले जाइए, C T power minus 1. देखो बेटा यहाँ पे C T power minus 1 यहाँ पे है, तो वो C T power minus 1 को हटा के आप क्या कर सकते हैं? एम्पियर यू कैन सब्स्टिट्यूट. Okay, so now I am bringing this here. So phi b is equal to m. देखो बेटा, L get cancelled. This L get cancelled. Okay, L get cancelled. So m L square t power minus 2. M L square t power minus 2 ऊपर मिला मेरे को. M L square t power minus 2 न्यूमरेटर में मिल गया. डिनोमिनेटर में c t power minus 1 है, तो एम्पियर सब्स्टिट्यूट कर रहा हूँ मैंने. तो एम्पियर सब्स्टिट्यूट कर दिया. Therefore phi b का आंसर मिला मेरे को m L square t power minus 2 per ampere. So this is the final answer. Instead of doing this, I memorize this. Then no problem, you can memorize. You should know the steps also. Okay. ml square t minus 2. ml square t power minus 2 a power 1. Step by step you copy, you will not forget. Only thing is 11th standard में dimension का जो भी पढ़ा है वो हमें implement कर रहे हैं. So if they ask you dimensions of the magnetic flux, dimensions of magnetic, the question is dimensions of magnetic flux. तो आपको क्या करेगा? How the questions they will be asked? Dimension of magnetic flux. So what they will do? This is the question. ऐसे make the dimensions of the magnetic flux is what? बोल के A B C D. ml square t power minus 2 a power minus 1 answer they will give. m l power minus 2 t power plus 2 ऐसा पूरा confuse कराएगा. तो आंसर में confuse कराएगा बेटा 4 options देके. You should not get confused. You should pick the first option. This is a good question. हो गया? Over. Recording is going on, na? Hello? Hello, बच्चों. Can you check? Recording is going on.
हाँ sir.
Yes, sir, recording is going on.
Okay.
Yes, sir.
Okay. हो गया? Clear up the board. After finishing, please tell me.
Yes sir. Done sir.
Next question, what we are going to learn one more question again. SI unit of magnetic flux. SI unit of magnetic flux. Single word is there. Just Tesla you can remember. So shall I run the board, girls?
Yes, sir.
Okay. Or one more question we are seeing. Suppose if you find difficulty in all the doing steps, you don't know, you forgotten all the steps. At least you remember this. ML square to a power minus 1. ML square t power minus 2 a power minus 1. But you should know how this all, how we get this formula. All the things you should know. Now next one more question. Write down SI unit of magnetic flux. SI unit of magnetic flux. Just one word you can say, but this word they never ask mostly. Tesla is the answer. SI unit of magnetic flux is Tesla. Sorry. Weber. SI unit of magnetic flux is Weber. बच्चों सारी बच्चों को बोल दिया मैंने. Weber. हो गया? Now there is a one more question. Define 1 Weber. Define 1 Weber. Next question, write down define 1 Weber. It is the flux produced. हो गया? It is the flux produced हो गया? Can anyone read please? I want to know whether you are able to see clearly. जल्दी read करो ना. Hey, anyone please read ना. Faliha, Aisha.
Sir, define 1 Weber.
Ah.
It is the flux produced when a uniform magnetic field of 1 Tesla acts normally on a area of 1 meter square.
That's all. Khalas. Very good boy. So 1 Weber is equal to 1 Tm square other flow. 1 Tm square. 1 Tesla meter square. Khalas. If they ask you one more question, MCQ में पूछा तो what is 1 Weber? 1 Tesla meter square. Just MCQ question only. No need to, even if you don't remember all the theory means, you just write down 1 Weber equal to 1 Tm square. That's all you have to memorize. Nothing else. Formula याद रखना. Next question. CGS. CGS unit of magnetic flux. Magnetic flux. Anyone tell me what is CGS? Anyone tell me what is CGS?
Centimeter gram second.
Centimeter, gram?
Second.
What is MKS?
Meter kilo second.
Kilogram?
Second.
Second, very good. तो CGS यूनिट को क्या बोलते हैं बच्चों? मैक्सल बोलते हैं, मैक्सल. So what is CGS unit of magnetic flux? Maxwell. So again they will ask you, define one Maxwell. Next question is, define one Maxwell. Please don't remember that, even if you don't remember the definition, this is not required. Definition अगर याद नहीं है, no problem at all for physics. But remember the formula बच्चों. Formula नहीं याद रहता कुछ नहीं कर सकते. 1 Weber equal to 1 Tesla meter square. You can write on framing word and all, you can write on your own words. 1 Tesla in 1 meter square area. Kala. So here, means define one Maxwell. CGS unit. तो 1 मैक्सवेल का शॉर्ट फॉर्म में लिख लीजिए. 1 मैक्सवेल इज इक्वल टू 1 मैक्सवेल इक्वल टू 1 गॉस into 1 centimeter square area. 1 gauss acts in 1 centimeter square area. So 1 Maxwell is equal to 1 gauss. GAUS. CGS unit में gauss बोलते हैं. 1 centimeter square area. So next one more question. All are one more question.
Sir,
Yes.
sir,
Just tell me.
sir,
I am
can you
having.
please read uh, the define one Maxwell, the second point?
Define one Maxwell. One Maxwell is nothing but it is here. CGS unit में बोल रहे हैं. Maxwell का mix में कर रहे हैं बेटा. देखो. So 1 Maxwell equal to 1 Gauss into 1 centimeter square. Gauss is a CGS unit. Centimeter also is a CGS unit because we want CGS unit. Magnetic flux is Maxwell. SI unit of magnetic flux is what we say. SI unit of magnetic flux क्या बोले अभी? Hello. SI unit of magnetic flux is what? जल्दी बोलिए. अभी करें ना हमें. वेबर बोला था ना. Hello girl.
जी, yes, sir.
SI unit of magnetic flux is Weber. आपके देखे अभी देखो. What is CGS unit of magnetic flux? So what is the question? CGS unit of magnetic flux. CGS unit of magnetic flux is Maxwell. So what is Maxwell? Maxwell बोला तो हो गया. So what is Maxwell? You should know ना. So CGS unit of magnetic flux is Maxwell. So what is one Maxwell? One Maxwell is equals to 1 Gauss into 1 centimeter square. So 1 Gauss into 1 centimeter square. पूरा देखो CGS field बन गया. So 1 Maxwell you can say 1 Gauss into 1 centimeter square. G means you won't understand. तो यहाँ पे लिखा हूँ साइंटिस्ट का नाम होता है Gauss. GAUSS. 1 Gauss into 1 centimeter. So 1 Maxwell is 1 Gauss 1 centimeter square. It is called CGS unit. अभी पूछ रहा है next question पूछ रहा है write the relationship between Weber and Maxwell. Weber and Maxwell का बीच का relationship बनाएंगे. So 1 Weber already I gave you. SI unit of magnetic flux is 1 Weber बोल के मैंने दिया हूँ. So what is 1 Weber? 1 Weber is nothing but 1 Tesla meter square. दिया था ना इसका पहला. Check करो in your note. Is it there? अरे बोलो बच्चों. Is it there or not?
Yes, sir. Yes.
So 1 Weber equal to 1 Tesla meter square. What is 1 Tesla? 1 Tesla will be equal to SI unit को हमें अभी CGS में convert कर रहे हैं. So 1 Tesla will be equal to 1 meter. If I ask you what is 1 meter, if I ask you simple question, what is 1 meter? There will be how many centimeters will be there? 1 मीटर में कितना सेंटीमीटर होता है? अरे बच्चों कोई आंसर करना भाई. In 1 meter, how many centimeters are there? In 1 meter, 100 centimeters are there na? Hello. 1 meter scale, how many centimeters are there? 100 centimeter is there. 1 meter में 100 centimeter is there. So like that, 1 Tesla में कितना gas होता है? 10 to the power 4 gas is there. 1 meter में कितना होता है? मीटर स्क्वायर होता है. तो 10 to the power 4 सेंटीमीटर स्क्वायर. तो मीटर स्क्वायर को सेंटीमीटर स्क्वायर बनाते हैं. यहाँ पे भी 10 to the power स्क्वायर को क्या करते हैं? स्क्वायर बना रहे हैं. सो 10 to the power 4 सेंटीमीटर स्क्वायर. 10 power 4 को ऐड करो 10 to the power 8. So this gas सेंटीमीटर स्क्वायर का हमें कैसा बोल सकते हैं? Maxwell से. हो गया. Otherwise, if you find difficulty, at least you remember the end formula. इतना ही मैं बोलूंगा. End formula तो याद रखो. 1 Weber relationship between the Weber and Maxwell. If they ask you, means 1 Weber equal to 10 to the power 8 Maxwell. How does 10 to the power 8 Maxwell has come? This is the steps. If you forget this also no problem, but don't forget this end formula. हो गया.
जी sir.
Hello. Please tell me now. Is it over or not? हो गया. Share the board. Share the board.
Yes, sir.
Okay, now next question. Define electromagnetic induction. Define electromagnetic induction. Chapter का नाम होता है EMI. What is the chapter name? Now only we are seeing the definition of the chapter name. So define EMI. Easily monthly installment नहीं होता है भाई. Electromagnetic induction होता है. Electromagnetic induction. Please write down the definition. जल्दी लिख लीजिए. It is the production of induced EMF. It is the production of induced EMF. It is the production of induced EMF and hence induced current. Induced EMF, electromotive force. Induced EMF से क्या बनता है? Induced current बनता है. So write down properly. It is the production of induced EMF and hence induced current. हो गया?
जी sir.
Due to a change of magnetic flux. Due to a change of magnetic flux. Due to a change of magnetic flux. Due to a change of magnetic flux in the closed circuit. Due to a change of magnetic flux in the closed circuit is called electromagnetic induction. So can anyone repeat please? Can anyone repeat so that I will check here, please? Jaldi kariye.
It is the production of induced EMF and hence induced current due to a change of magnetic flux in the closed circuit. It is called electromagnetic.
Very good, very good girl, very good girl. Now, अभी जो भी मैंने explain किया था ना, all the concepts, all the Faraday का diagram and how the deflection is produced in the coil one. So regarding that, we will write a law. Okay, so you should understand the law also. So write down the question, Faraday's law. हो गया? Faraday's first law. Please write down. Faraday's two laws are there. Faraday's first law, Faraday's second law. So first you write down the first law. Whenever magnetic flux changes, whenever magnetic flux is changes, whenever magnetic flux changes, an EMF is induced. Whenever magnetic flux changes, an EMF is induced. हो गया? हो गया? Can anyone repeat?
All magnetic flux changes and EMF is induced.
Very good. So whenever the flux changes, magnetic flux change हो रहा है, तो EMF is induced बोल रहा है. So whenever the flux is changes, EMF is induced बोल रहा है first law में. I will write down the second law. Write down the second law. The magnitude of the induced EMF okay. Can anyone read? Suraya, can you read?
Yes, sir. The magnitude of the induced EMF is equal to the rate of change of magnetic flux.
Very good. So can anyone see here the magnitude of the induced EMF? तो यहाँ पे एक वर्ड होता है induced EMF. इसको देखो हमें कैसा फार्मूला बना रहे हैं. तो induced EMF, यहाँ पे एक वर्ड है induced EMF. तो induced EMF का सिंबल होता है E. Induced EMF. EMF means we put E. So induced EMF is equal to, is equal to rate of change of magnetic flux. Rate means what? Rate refers to what, right? Refers to what in physics?
Sir, the flux.
रेट का मीनिंग क्या होता है फिजिक्स में? रेट का मीनिंग क्या होता है?
Time. By time.
वेरी गुड चिल्ड्रन. टाइम होता है. रेट मीन डिवाइड बाय टाइम. रेट ऑफ चेंज ऑफ फ्लक्स. रेट ऑफ चेंज ऑफ फ्लक्स. फ्लक्स का सिंबल क्या होता है? फाई होता है. तो रेट मींस टाइम. टाइम. रेट चेंज ऑफ फ्लक्स. चेंज बोला था डिफरेंस. फ्लक्स मींस फाई. डी फाई बाय डी टी. EMF equal to in the magnitude of the induced EMF. So induced EMF हो गया is equal to rate of change of flux. EMF is equals to d phi by dt. EMF is equals to d phi by dt. Because it's not value also. Okay. Yeah.
सर हो गया
Right of the board, all of you.
Yes, sir.
Now Lenz law. What is the set Lenz law? Another scientist come here. करने के बाद में एक साइंटिस्ट आ रहा है, लेंस आ रहा है, लेंस. साइंटिस्ट का नाम होता है लेंस. So write down Lenz law. L-E-N-Z, Lenz law. What is lens? Lens क्या होगा? तो सुनिए बच्चों, थोड़ा theory सुनिए. Now a coil is there. The coil explanation. The coil is there. So coil is connected with the galvanometer. Coil is connected with the galvanometer. तो Faraday क्या बोला भाई? Faraday क्या बोला? When you make a magnet forcibly towards the coil, when you move the magnet forcibly towards the coil, yes, deflection is produced. सही है ना? अरे बोलो ना भाई. लो बोलो ना.
हाँ सर
Do you agree this concept? When you make
Yes,
the magnet move very forcibly towards the coil, yes, deflection is produced. This is what Faraday said. So the same thing, I'm going to put it in a symbol form. So induced EMF, यहाँ पे the current deflection का हम क्या बोल रहे हैं? Current is produced. Current is nothing but induced EMF is produced. So first we say EMF, induced EMF. EMF के बाद क्या बोल रहे हैं? Current के बारे में बात कर रहे हैं. Induced EMF, induced current is produced. So induced EMF is produced. Induced EMF is equal to rate of change of flux. Rate of change of flux. So ये कौन बोला था भाई? ये Faraday बोला था. So what, when you make the movement of the magnet, magnet को मैंने move कर रहा हूँ, so around the magnet what is available? Magnetic field lines are there. खाली सिर्फ magnet का तो बच्चों आप नहीं सेक देखना है. खाली सिर्फ magnet एक इतना बड़ा rod is moving, single rod is moving, single rod. The magnet ऐसे rod जैसा feel नहीं करना है. So you should know that, you know the physics. Around the magnet, North Pole, South Pole जब बोला तो around the magnet what is available? We know that magnetic field lines are there. तो क्या होता है भाई? Magnetic field lines are there. We cannot see the magnetic field lines are there. So this magnetic field lines, so many magnetic field lines, it goes and hits the coil. That means what we say, this magnetic field lines goes and hits the coil means rate of change of flux. Flux means what? Flux means नंबर ऑफ मैग्नेटिक फील्ड लाइंस. तो यहाँ पे बोल दिया आराम से, मैंने फ्लक्स बोल दिया. तो फ्लक्स बोल के ऐसा चुपचाप नहीं बैठना है. तो फ्लक्स मींस इनर माइंड यू हैव टू थिंक दैट फ्लक्स का फार्मूला आप सोचना है. तो व्हाट इज द फ्लक्स फार्मूला? मैग्नेटिक फील्ड लाइंस प्रोड्यूस्ड इन ए गिवन एरिया बी ए cos थीटा. दिस फ्लक्स का फार्मूला क्या होता है बेटा? बी ए cos थीटा. सो बी इज व्हाट? मैग्नेटिक फील्ड लाइंस. ए मींस व्हाट? एरिया. cos थीटा मींस व्हाट? एंगल विद द मैग्नेटिक फील्ड एंड एरिया. So when you make the movement of the magnet, that means these many factors it should be there in your mind. That means when you forcibly make the magnet move towards the coil, what happens? This magnetic field line hits. अरे भाई एरिया भी कवर होता है और मैग्नेटिक फील्ड लाइन, ये देखो मैग्नेटिक फील्ड पर इसको मार रहा है. Therefore what is produced? EMF is produced. So see how many time, how many things are inside जा रहा है. Therefore, what is simply we said that what is induced EMF? EMF is directly proportional to rate of change of flux. EMF is equal to d phi by dt. Simply we say EMF is equal to just मतलब concept को कुछ half baked food जैसा होता है ना, ऐसा नहीं ख्याल करना है. EMF is equal to d phi by dt. इतना ही सोचे तो नहीं काम होता है. EMF is what? How the induced EMF is produced? Rate of change of flux. Rate of change of flux means what? फ्लक्स होता है जब मैग्नेटिक फील्ड लाइंस कहाँ पे होता है? जब मैग्नेट मूव करने का टाइम पे ये मैग्नेटिक फील्ड होता है. तो ये मैग्नेटिक फील्ड कहाँ पे मूव हो रहा है? ये पर्टिकुलर एरिया में. यहाँ पे इस एरिया पूरा छोड़ दो, तो ये पर्टिकुलर एरिया में बात कर रहे हैं हमें. तो cos थीटा क्या होता है? एंगल बिटवीन द मैग्नेटिक फील्ड एंड एरिया. सो दिस मेनी फैक्टर्स आर इन्वॉल्वड. Therefore, simply if you say what is induced EMF, yes, what is Faraday said that Faraday बोला भाई induced EMF is produced when a rate of change of flux is there, or induced EMF is directly proportional to rate of change of flux. ना काम नहीं हो सकता है. So indirectly, inside, you have to go and think. Okay, this is about the Faraday's law. What Faraday ultimately finally he observed, finally he said, conclusion क्या बोला भाई? Yes, rate of change of flux is there. Rate means time. अरे भाई पहला सेकंड में मैग्नेट यहाँ पे था, दूसरा सेकंड पे यहाँ पे आ गया, तीसरा माइक्रो सेकंड पे यहाँ पे आ गया. Therefore change of time is there. मूव कर रहा हूं मैंने, फर्स्ट सेकंड, सेकंड सेकंड, थर्ड सेकंड, फोर्थ सेकंड, 5 सेकंड, every second I am moving. So that means time, difference in time. What I am moving? I am moving magnet. For you it looks magnet. For me, for a physics student, it should not see as a magnet. जब magnet move कर रहा है तो आपका दिमाग में क्या चल रहा है भाई? Magnetic field is moving. Area is calculated. Cos theta is calculated. All these things it should strike in your mind. Therefore, d5 by dt. Rate induced EMF is rate of change of flux. जब बोला तो मैंने आपको सोचना है कि फ्लक्स के अंदर कितने चीज होते हैं. एक चीज B होता है, एक चीज ये होता है, उसके बाद क्या होता है भाई? cos theta. So these many factors are there. Okay, now come to the point of lens. Lens क्या बोला? So first Faraday's law you understand, I hope so. Induced EMF is produced in the coil. How? When rate of change of flux is there. Okay, now whatever the magnetic movement जब भी आ रहा है ना, magnetic movement is produced. तो मैग्नेट आपको जब आपको मूव कर रहा है, देखो ये काइल होता है बच्चों, और सुनिए, ये काइल होता है, ये मैग्नेट होता है. तो ये काइल के पास से मैंने फोर्स से मैंने मैग्नेट को मैंने मूव कर रहा हूँ, तो करंट यहाँ पे प्रोड्यूस हो रहा है. ये जो भी इंस्टेंट करंट, जो भी इंड्यूस ईएमएफ ये काइल में जो प्रोड्यूस हो रहा है ना, तो दैट करंट what it happens means whatever it comes closer, so it opposes the movement, it opposes the movement. Are bhai bas. That means when one fellow strikes you, okay, first time if he strikes means you can tolerate, are bhai itna maar diya bhai. Second time, third time, fourth time if he strikes means you say are bhai bas karo. You say na, are stop it, enough is enough. You are saying na, like that. When the magnet is moved very forcibly, induced EMF is produced. This the continuous EMF is produced means ये इतना नहीं बोल रहा है, अरे भाई बस करो. That means it opposes the cause. It opposes. So when we use the word it opposes, so what we say means negative sign. So this is what the lens taken. So lens, what he said that when induced EMF is produced because of this rate of change of flux, the rate of it opposes the cause. It opposes the cause. So that word it opposes the cause. Cause means what? कौन जो प्रोड्यूस किया भाई? ये रेट ऑफ चेंज ऑफ फ्लक्स थ्रू द मैग्नेट इज प्रोड्यूस. तो वहां पे हमें नेगेटिव साइन डाल रहे हैं, तो वी स्टॉप. सो इट अपोजेस. अरे बस करो भाई. ओके, so first you write down the statement, you will understand very clearly. Write down the statement. Lens law, it states that
Shifa.
hello, any doubt? It states that the direction of induced current, अरे बच्चों अभी थोड़ा ला है ना, जब भी मैंने टीच कर रहा हूँ ये ला एंड ऑल, यू गेट लिटिल बिट कंफ्यूज्ड. आपको समझ में आने के लिए थोड़ा टाइम लगता है. व्हेन आई टीच यू द डायग्रामेटिक कॉन्सेप्ट्स बोर्ड का क्वेश्चंस जब देखेंगे ना, 1 मार्क क्वेश्चंस, नेक्स्ट क्लास आई टीच यू व्हाट इज कॉल्ड इंड्यूस्ड ईएमएफ, व्हाट इज कॉल्ड इंड्यूस्ड करंट. इंड्यूस्ड करंट कैसा प्रोड्यूस हो रहा है, कॉइल में कैसा प्रोड्यूस हो रहा है, क्या, ऑल दिस थिंग्स व्हेन यू सी all 1 mark conceptual questions na, then still you will understand, very clarity will be there. Okay, so first you write down the statement. It states that the direction of the induced current is such that the direction of the induced current is such that it opposes the cause. The direction of the induced current is such that it opposes the cause. It opposes the cause which produces it. That is, it opposes the magnetic flux. Now take down the formula. Lens law का formula, EMF will be equal to minus d phi by dt. So this is Lenz's law formula. Just you put the negative sign. Faraday's law में minus डाल दिया तो Lenz's law बन गया. Can anyone repeat the statement, please?
It states that the direction of the induced current is such that it opposes the Gauss, which produces it. That is, it opposes the magnetic flux.
Who is that?
Suraya.
Right. Good. 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 Now, next topic. Good questions. So, from these definitions, we are going to see some board questions. Okay. Some concept-based board questions you will see. Then you will understand very clearly. Okay. Hello. Hello. Hello.
Sir.
Are you getting my voice?
Yes, sir.
So first, listen the question very carefully. Questions are. Please try to understand the question. When magnetic field is changing, here where is the magnetic field? Where is the magnetic field? Cross is the magnetic field. Imagine that the cross are the magnetic field. So can you tell me what is the meaning of cross?
It is going inside the board.
Who is going inside the board?
Magnetic field line.
Very good child, very good child. So magnetic field line go. So and first you write down the question हो गया ना? Question आपका copy कर लेना. Hello. Question,
Yes,
did you
sir.
copy the question? After copying the question, now write down below that answer separately because concept, all are concept based things. So don't get confused. Here the question is over. Now you write down answer separately. Okay, answer. Now you said very clearly, very beautifully. You said that the cross means magnetic field lines are going inside the board. So first point I'm writing, magnetic field line goes inside the board. Inside the board. Very good, children. The first concept you said very clearly, magnetic field lines are going inside. Very good. Now, when you say Magnetic cross means magnetic field lines are going inside. That means in which direction current is produced in the coil. You know,
Clockwise?
fourth chapter में मैंने teach कर दिया मैंने सब कुछ किया सब. Fourth chapter में we have seen.
Sir, is it clockwise?
Who is that?
Suraya.
How?
Sir, the palm rule.
Palm rule, okay. Magnetic field line goes like this. ये तो palm होता है भाई. This is called palm rule. तो palm rule में
No,
यहाँ पे
anti-clockwise.
हाँ. What to use? Only Suraya is please answering. Remaining all the people, what you are doing, I don't understand. Please.
The right hand rule.
Right hand rule. Okay, what is right hand rule? You tell me. जल्दी बोलिए बेटा. What is right hand rule? ये है right hand. Fleming's right hand rule. Anyone? अरे जो moving charges पूरा complete कर दिया. Who is that happily sitting? No one is answering. Why? What is the problem, बच्चों? क्या हो गया भाई? Ayaz, Ayman. अरे Ayman? Monkey fellow? फलीहा? मन पटेल, मोहम्मद अली, मोशाहिद, नव्या, निश्ता, नूर सलमा. ये कौन है भाई? नूर सलमा, न्यू स्टूडेंट. हेलो. रैयान, रिदम, शरिया, शेख मोहम्मद, सुरैया, टिमोथी, जोहा. Who is Noor Salma? Please tell me na, reply na. Please बच्चों reply me. Who is Noor Salma? Anyone is there Noor Salma? Okay. So please listen very carefully. You know that already I taught you right hand thumb rule. Thumb rule आपको मालूम है. What is right hand thumb rule? So देखो बेटा, right hand thumb rule means this is thumb and this is the folding fingers. Suppose current is moving in this direction. So moving direction, current का direction में thumb रखना है. Then the folding direction will give the magnetic field lines. Okay. Straight conductor means I am taking the current direction. यहाँ पे straight conductor नहीं है, यहाँ पे coil दिया है. तो coil देने का टाइम पे I cannot take the current direction. I can use the folding fingers. You can use, if this is the magnetic, if this is the current direction, this is magnetic field line. If this is the current direction, this is the magnetic field line. Vice versa, we can say. याद आया? Right hand thumb rule याद आया? अरे बोलो ना भाई, yes or no? Are you getting my voice or not?
Yes, sir. Yes.
हाँ, right hand thumb rule तो याद आ गया. तो right hand thumb rule में देखो बच्चों, if I take this is the magnetic field line and this will be the current direction. तो यहाँ पे देखो magnetic field line अंदर जा रहा है. तो magnetic field line cross का तरफ मैंने thumb रखता हूँ. तो cross अंदर तरफ. तो मैंने इसको देखो मैंने अंदर तरफ रख दिया. Now you see the folding direction. Folding direction is going in this direction. So my folding is in this direction. Therefore, this direction is what? This direction is what direction? ऐसा फिर इसको क्या बोलते हैं?
Clockwise.
Clockwise बोलते हैं या anti clockwise बोलते हैं?
Clockwise.
Clockwise बोलते हैं. Very good. So when magnetic field goes inside the board, that is clockwise direction. Clockwise direction. Current is produced. Clockwise direction. Current is produced in the coil. But we don't want current direction. We want induced current. हमें पूछा है how the current is induced. That means induced current he is asking. What is the induced current? Current is favoring in this direction. Okay भाई, current is going in the clockwise direction. तो clockwise direction आप लिखा तो आपको आंसर हो जाएगा. You should oppose the cause. तो उसका opposite बोलना है. So how the induced current is produced? Induced current will produce in, इसका opposite क्या होता है? Clockwise का opposite क्या होता है?
Anti-clock.
Yes, very good. But induced current produced in anti-clockwise direction. So this is your right answer. After knowing this perfectly, one by one, so totally there are 10 questions, are there 1 mark questions. In next class, we will see all the diagram based questions. One by one question, if you understand very thoroughly how the induced current is produced. So current, there are different words is there. Current means normal current we say. Induced current means uska opposite bolte hain, induced current. Because lens law, by using the lens law, we use this. Lens law क्या बोल रहा है? Negative sign depicts the which opposes the cause. तो इसका अपोजिट बोलना है. See, this is the magnetic field line and this is the current direction. तो clockwise बच्चे बराबर में लिख देंगे तो उनको 0 मार्क मिलेगा. तो clockwise का अपोजिट बोलना है. इंड्यूस करंट होता है, अपोजिट बोलना है. तो clockwise डायरेक्शन होता है. अभी यहाँ पे लिखना है एंटी क्लॉकवाइज डायरेक्शन. So those who are very familiar, they will get immediately 1 mark question anti clockwise direction. So this is the right answer. Please note down. हो गया? हो गया?
जी सर.
So a lot of questions are there. 10 more questions are there. You will see the next class. Okay, all board questions, diagram based questions, all 1 mark questions. You will see. We will continue next class. Take care. Bye bye. See you. Bye.
Thank you sir.
Thank you, beta. Any doubt is there?
No sir.
कुछ भी डाउट हो तो मेरे को व्हाट्सएप कर दीजिए. ओके.
जी सर.
टेक केयर. अल्लाह हाफिज. बाय बाय.